So the benefit of being the last of the day is you don't have to stop on time. No. So feel free to ask questions as we go along. We will be recording this, so we'll be trying to I'll repeat the questions. But basically, I'm going to talk to you about some of the things we've been doing in trying to help manage software assurance. So the label is the idea that some software comes along and you can actually get some idea of what kind of energy was put into giving assurance about that. So let me walk through what we've been doing. A little bit about me. I take pictures of sharks when I don't want to play with software problems. Work on several different standards efforts. Hopefully some of those mean something to you. What I want to talk about, though, is that in the overall security of an enterprise, a lot of things have changed over the years. We've learned a lot of things that don't work. I think any of us that have listened to any of the talks this week realize that you're not going to be able to secure against everything. You're going to have networks that connect to everything, and so you really need to deal with that rather than just try to know everything on your network and patch everything and be aware of everything. So one part of that is to also get an understanding of the attackers. Not talking script kiddies, we're talking people that are in the business of attacking. So they have a cycle, they do things in an order, and if you can understand that, then you may have a leverage into keeping your business working. So if you think of them as an advanced and persistent threat, the buzzwords that a lot of people use, you probably aren't going to see the attack. You're not going to be able to keep them out. And they are not the hacker of, that just is randomly doing things. So that process that they follow, and this is just, kind of a general understanding purpose, is they're going to be looking at your systems, not as you design them, but as they actually are out there. So attackers are going to get to know the real system. And if you don't also get to know your real systems, then they're going to have a big advantage. So don't just go by design documents and the requirements. Look at how they're actually deployed, actually in use, and actually configured, because you're going to find a lot of gaps between what you thought was there and what's actually there. So they're then going to figure out some kind of payload that can be used to take advantage of your systems as they're actually in place, and then they're going to go and try to get a point where they can now do what they want to do. Now, some of them will be trying to steal data, some will be trying to steal resources, lots of different reasons, and they're going to want to keep that investment. So they're not going to want to be seen, they're not going to want somebody to expunge them, and they're going to just continue to work that. So that whole idea, this flow of things, is just something you need to understand, be aware of, and make sure you're not just sitting at your system and looking at it. So what we need to do is actually look at the adversary, understand how they attack, what techniques they use, what are they going after, what's their objectives, so that we can actually make sure that the right parts of that net are protected, or that we have defensive men working to help us. So really looking at how do they go about their attack. They're limited into your networks, into your systems, into your software, how it's set up. They're not omniscient, they're not magical, so they have to be within that. Another part of this is that you really need to think about other people that may be a similar target to you, and so that you can inform each other, or maybe it's an upstream partner or a downstream partner. There's reasons why you may want to be talking to them, establishing trust NDAs or something, so that you can actually see trends before you're the victim. So the other part of this is to be able to react to that. Now, I'm going to focus on the development side of that, but there's also the operational side. So this whole idea here is your development efforts should understand that operational context and what's actually coming at you, what kinds of flaws are the attackers looking for, and have you done the energy necessary to make that harder? So it's basically an attack-aware, threat-driven idea. And a lot of focus will be on that operational, training your users, making sure they understand what an attack looks like, getting things patched as fast as possible, configured and down and locked down as best. All that is important, but there's also some strategic things we're doing here. And the real focus, how is your enterprise architected? How is your development efforts and your integration and system engineering taking advantage of that insight and making sure that it's aware of things that your operations group may be seeing. So rather than talking about mitigation compliance from on my up to speed on what I was told to do, the idea here is to really think about detection and response as a reactive and evolving set of things where you basically want to make sure that your development team or the people you have doing development for you are putting the right energy against the right things. So a piece of software comes in, it'd be interesting if it had a tag that talked to you about what they've done, and then you can balance that against what kind of attacks you're expecting and whether enough of that energy has gone against those different kinds of issues. So there's going to be a talk hopefully tomorrow that will be focused on this whole cyber threat intelligence, but basically it's, what are you seeing? What do those things indicate? Do you have incidents? What kind of techniques are being used? What are they actually going against? What other things are the attacker doing? And who was it that did the attack, and what can you do about it? So this whole idea here is actually knitted together in something called the Structured Threat Information Expression, and there's a lot of energy out in the information sharing and threat sharing space about using this concept to actually exchange with others what you know about an incident or an attack or the mitigations. Now, you may not share all of this with everyone. Who you trust and with what information you trust, what kind of legal agreements you have, will flavor this into, I'll only give observables or indicators to some people. Other people's I may talk about what campaigns I've seen and so on. So in the context of this, they all knit together, and what I wanted to focus on here is the exploit targets, well, CVEs, publicly known vulnerabilities in packaged software, and CWEs, things that can go wrong in code, design, or architecture that can lead to vulnerabilities. That's part of how they talk about the targets. And then the TTPs, the common attack pattern. Let's see. I had this problem this morning, and eventually this is going to transition. But basically, the common attack pattern enumeration is a way of giving you an insight in a standard way of what kinds of techniques are they using. So, there we go. So, I don't know why that takes so long. So, this isn't the only group that's making use of these. If you look out at the OWASP threat work, CVEs, CWEs, CAPEX are something they talk about. This group, OWASP, has a top 10 list. You may have heard of it. They also link it to CWEs for a little more fine-grained detail. And in CWE, we actually point to the OWASP top 10, so there's a good cross connection there. And SafeCode, which is a group of industry players that make a lot of large software products, Microsoft and Nokia and others, they use CWE to talk about what have they been vetting for, as does the federal government. The CIO metrics that all the federal agencies are supposed to talk about what they've done in assurance calls out KPEC and CWE as a way of making sure that different agencies' answers can actually be combined and compared and contrasted. In the DoD, they've gone a step further. They actually have a software assurance part of their guidance, and they have a standard table that they expect all projects to report on, and they've called out specifically these things. The motivation of that was a little public law that came from Congress, and basically they said that we want you to address software assurance, and this is the definition we're giving you. Well, what the DoD did is they said, okay, there's a couple key concepts here. There's confidence, has to function as intended, and it has to be free of vulnerabilities. So they went about putting that table together, which had all these different kinds of measures and metrics in it, and you can basically map which of those measures or reporting activities would help you make the case that you're actually gaining confidence that it does function or it's free of vulnerabilities. So they actually have guidance out there. There's a website called the Defense Acquisition Guide. They, basically explain how they're using these things, and so that's all available to all of us. Now, I'm pretty sure everyone here knows what a SQL injection flaw is, and how somebody attacks it, probing the fields, looking for response, user input. Well, that's really what KPEC is capturing that and describing that pattern in a narrative form and then structuring it a little. So the whole idea of there's a weakness and there's a pattern that would be used to attack it is a key part of this. So things like pen testing, well, you can link it to the weakness that those pen tests are effective against. Or you can also think of it as misuse and abuse test cases to find residual weaknesses in your activity if you couldn't do static analysis or other kinds of things. Because, you don't want to end up with this kind of situation. Or maybe this is actually a good one because you actually have evidence that your security controls were circumvented, but the question is how or why, what was missing. And so in an application, that could be a cross-site scripting issue or a SQL injection flaw. So it'd be great if we actually had that kind of track of what's going on, but in software we quite often don't. So KPEC is out there. It's a thing to make use of, and it not only has attacks against software, it has network traffic, some physical attacks against IT elements, social engineering, and supply chains. So there's a bigger world of things in the attack patterns. So a couple of years ago, before the tsunami hit Tokyo, I was visiting, and there was a security operations center showing their customers' networks, and these were all the SQL injection attacks that they were sensing in their different customers. And then they showed me Asia, and I said, wow, it's a lot less. And I said, oh, sorry, we had Beijing off. So, these are very prolific. There's a lot of them out there. And in CWE, we have a description of it. In KPEC, there's a description of the actual attack pattern. So, some people, if you just look at the description of the weakness, they really can't get their head around how somebody would actually make use of this, how I could architecturally protect against it, or so the two of them together really make a nice pair. Now, you may have also seen this if you've looked at OWASP documents. We've actually borrowed it for describing how attack patterns and weaknesses work together. So if you have a known threat actor, they're going to have a couple different attack approaches that they're good at. And those are going to be effective against different weaknesses. And the goal is they want to get at your assets or functions and have an impact, either an impact where they degrade what you're doing, or maybe it's they get access to your resources. So the whole idea of a concept we talk about is engineering for attack, is these controls. I'm not talking about security controls only. Running static analysis, doing a design review, changing the functional allocation so that the boundaries are in different places, allocating functions to more than one user. All of those are perfectly good controls to impede the ability of the attacker to protect against weaknesses that you can't remove. So the whole idea here is that you want to do these assurance activities and you want to record that. And so you want to be able to say, here's a software product, here are all the different things we've addressed, and have the customer be able to see that quickly. Because you don't want an actual successful path through there. So in CWEs itself, you can find this common consequence which has these technical impacts. So it turns out that when a weakness actually manifests in the application and it's in an exploitable configuration and they actually exploit it, only a couple things end up happening. So, whoops, I guess I don't have it here. I'm going to explain, there's 8 of them. Basically, you can read data you shouldn't, you can change data, you can escalate privilege, assume identity, and the full list of 8, because you can only remember 5 things, right, is a little later. So remember that, the technical impact. But the other part we have here is we also talk about the detection methods. So what kinds of activities, tools, procedures could help you figure out if this weakness was going to show up in your system. So that's another part of this that we're putting together. So the other part of this is those technical impacts may have different meaning to you depending on what your software is actually doing. So if I have 2 pieces of software that are basically identical except they have different data. So if one's very private data and one's data that's going to be put on a website is public, well, a flaw that allows somebody to read that data is going to have different meaning for those 2. So the idea is to understand the context of your applications, because one may be internal web-based retailer, another is a health maintenance, but they're using the same technologies, but there's different norms of behavior or different priorities. So the whole idea here is that those 8 technical impacts, for a specific application, you may say, I really want to focus on number 1, and number 6 and 5 and the others are much lower priority. So this is a way that you can talk to the customer. These impacts have no technical understanding needed. It's just your application is going to allow the data to be read that you said you didn't want. So the idea here is, rather than getting them into vulnerabilities and weaknesses and coding, they can actually just tell you what kind of impact they want to focus on, and then you can use that to lead to which kinds of activities you want to aim at. We've got examples up on the CWE website as part of something we call a Common Weakness Risk Analysis Framework, trying to build those little stories about what's important for a piece of software. We have them across different technologies and across different business domains. They're more exemplar to try to get you the idea. You really need to do your own for your business or your piece of software. But the business value context is what we're really focusing here on, and that's part of something called the Common Weakness Scoring System. So we're trying to influence the tool vendors to allow you to specify the business value, and so that their sorting of results could reflect what you feel is important for that application, not what they feel is important based on how good their tool is finding something or such. So this is all in the handouts here. So the technical impact scorecard is that capturing of a vignette, the weighting of those different technical impacts, and how it relates to the business value of different failure modes. Now there's other factors that will be in there, like how easy is it to exploit this kind of issue, how often does this kind of thing happen in normal code bases. So it's not the only thing, but it's bringing in an important aspect into the equation. So this is just an example, it's up on our website as well, where different weaknesses, different failure modes can have different weights. And basically, depending on the context, the same exact problem could be really important or not so much. So here's an example of, a source code analysis tool has some findings. If you actually could put together that technical scorecard about the context and what's important, you could reorder those findings so that the things that really are dangerous, given what that application is doing, are the things you go after first. So if you step back a moment, you could think of this in many contexts, not just tools. So if I figure out which of these weaknesses I want to go at, whether it's the ones that lead to some failure mode or somebody told you to do the top 25 or something, you're going to have a bunch of different capabilities you can bring to bear. So it may be different code review manual with some scripts, maybe full-blown tools, or some testing services. So the idea is that there's some things you really care about, and you want to figure out how to marry these things together and have comfort that you've addressed them all. So these idea of coverage and which things are better at finding which is an important part. It's not just go out and get one tool. So another way of saying that is that you're going to have static analysis, dynamic analysis, some blend of them. Different issues will be better found or more reliably found by different approaches, and you actually can then start making maybe a table out of these, and some of these also can then maybe be arranged by phase. An architectural analysis would obviously be first, not in this table obviously, but so taking that idea, you've got some kind of a notion of a life cycle, whether it's waterfall or some other, and the idea is that you can bring in activities. So which ones are better at finding what kinds of things? So we went through and started looking at CWE about a year ago, and we had already been recording things about, well, what we wanted was discernibility. We already had where we thought you could mitigate it, but not where I can fix it, but where can I first notice that it's there. So what we've done is come up with this notion of these different buckets, and then here's the impact groupings. And so the idea would be that if you're at some particular place in the life cycle of your software, where could you focus at? We went through all the CWEs, so what kind of impacts are from what kinds of weaknesses. We have that information in there. So the notion would be that you could eventually say, okay, what can I focus on given I'm here? And the good news is we're almost there, and this is almost not notional. Basically, we've got different kinds of assessment methods mapped out. We already have the impacts, and there's a study, which, good, you can't read this, This is a fuzzed version of a report from IDA that DoD had done, and basically it has almost the same idea. The columns, what kind of assessment activity, the rows are what kinds of weaknesses does that address, and it's going to be coming out this December, January. And we're going to make use of that data and incorporate it into CWE so that we can actually take that notional table and make it a real table. And so that you can then look at what kind of activity are you considering, what kind of impacts are you trying to remove, okay, what weaknesses would be a good target for that activity, not the whole thing. So this will actually show up on our website in an area called the Software Assurance On-Ramp. So we've also been trying to say, okay, rather than a collection of weaknesses that everybody can go study and become a historian about, what can I do for a program manager or a developer to apply this to them? So the Software Assurance On-Ramp is that area. The very first step is engineering for attack. So talking about that idea that I presented a little while ago. And then this area about what kind of assurance activities you can do to address what kinds of impacts will be there as that kind of a table. But I'd also like to offer, and the whole point of this talk, is that that could also be a tag that came with your code. So let's say somebody else developed the code, you had, some group decided to buy it. Well, if it came in with that assurance tag, you could look at what it's going to be used for, and then look at the tag and determine whether enough energy was put on the right kinds of things. And if there wasn't, then you could open up a negotiation of, okay, is there things you can get the developer to do more of, or do I need to actually put in maybe an application firewall or change, the boundaries of the system? But the idea is to get insight into those and have it be with the software and not be at the CWE level, but rather at the business impact potential. And so really interested in any feedback, additional ideas. It should be coming out in about a month or two. But if people wanted to see advanced copies, I'd be glad to share it with you. And once again, I thought I had 50 minutes worth of material and I raced through it in 30. So if you have questions, I'd be glad to entertain them. So question was the tags, whether they live inside the code. So my thoughts currently are that there is a tagging scheme already out there in the world. ISO has put it together. It's called Software ID tags. And one of the enhancements to the Software ID tags is an assurance area. So my thought is to make use of that, rather than try to create some whole new way of doing it. And my problem was that if I did it by CWE, I was going to have a massive part of that. So in fact, in December, we're having a working group session at MITRE in Washington, and a gentleman from NIST who's working software ID tags in the NRL, the National, yeah. So it's basically a catalog of known software and checksums and all kinds of other metadata. Well, he's looking to use the new version of the software ID tags to capture more information, and so hopefully this is an area that I can get him interested in as well. But the whole idea is to try to make use of things that are coming out to capture this and convey this. Yeah. Okay. Yeah. So the software ID tags, the question is, would there be security on the tags? So There's an organization called Tag Vault that actually signs tags. So they could sign tags and certify them. Other organizations could sign their own tags if they had a, if that was appropriate. But there's mechanisms for that in that specification. Any other questions? Well, I appreciate your attention, and I'll be around the rest of today and tomorrow. So have a good conference. Thank you.